Welcome to VW 8.1. Today we're doing the final unit of semester 1, and this is called Sequences and Series. So this will be a short unit. We're only going to have 3 total homework assignments on it, and then the quiz to wrap it up. So let's get right to it. This says write down the first 6 terms of the following sequence. So notice how it's defining the sequence right here for you, and it's saying A sub n. So A sub n, this is kind of like a general formula, and that's going to help you figure out all the terms. So the first term is going to be A sub 1, meaning we're going to plug in 1 for the n values. So I can see if I plug in 1, I get 0. So now for A sub 2, you're going to plug in 2, you're going to get 1/2. And now we keep going, 2/3, 3/4, 4/5, and the last one, 5/6. And those are your 6 terms. Now notice if you have the general formula, that's useful because let's say I wanted the 100th term, you simply plug in 100 and you'd get 99/100. That's why the general formula is pretty useful. Let's try another one here. Write down the first 6 terms of this sequence here. So it's giving us a b now, so we'll write that. B sub 1. Plug in 1 here. This part's particularly interesting, so I want you to highlight this. What this is going to do is make the signs alternate, meaning it's going to alternate between positive and negative. So for example, let's plug in 1 right there. That's going to be positive 1 times 2, which is 2. Let's plug in 2. And I plug in 2 here, that makes the power odd, which makes this -1 cubed. So that's going to be -1 after you plug in 2 for both of these n's here. Let's keep going. We're going to plug in 3. So if I plug in 3 here, this thing is now positive. This is now 2/3. The 4th term, that should be negative. And if I plug in 4 here, that's 1/2. The 5th term should be positive, and that'll be 2/5. And the final term, that should be negative. If I plug in 6 right there, I get 1/3. And we're done there. So now it says determining a sequence from a pattern. So essentially what we're trying to do is we're trying to figure out the general formula. So this takes a bit of intuition. So I have to look at this and figure out if I plug in 1, I want this term. If I plug in 2, I want this term. If I plug in 3, I want this term. If I plug in 4, I want this term, and so on. So clearly, if I make this a fraction, I can see the bottom is changing with the number 1, 2, 3, and 4. So that's going to tell me in my formula, I'm going to write A sub n, your denominator should be n. I can also see that there's an e every single time, so I know there has to be an e here. And finally, the powers are changing by 1 every time, and again, that matches what we're plugging in, which means the formula should be e to the n over n. And we can verify by plugging in 1, 2, 3, and 4, and it does work. Let's try the second one. A sub n. Now notice how these are fractions. Let's make 1 to a fraction to look at it. Now I can see that there's a 1 in every denominator, which means I definitely want a 1 here. And this right here, we should notice it's powers of 3. So it's multiplying by 3 every time. So I can put 3. Now if I just put an n right there, that's not going to really do it because, let's see what happens. If I plug in 1, I get 1/3 to the 1, which is 1/3. This doesn't match this. And you can see if I plug in 2, I get 1/3 squared, which is 1/9. So notice how I'm pretty close right here. So to fix that, what we're going to do is a little trick. We're just going to do -1 right there. Because if I do -1, let's see what happens to all these numbers here. That will now become 1 over 3 to the 0, which is 1. This will now become 1 over 3 to the 1, which is 1 over 3. So notice how this is checking out, which means this is the proper formula. Let's try the next one. This one I can see, if I plug in 1, I want 1, 2, I want 3, 3, I want 5, 4, I want 7. So I'm already noticing that every single term is going up by 2, plus 2, plus 2, plus 2. So to help, I'm going to write, there has to be a 2n in there. Because if I'm having a 2n, that's the only way I can make each of these go up by 2. Now the problem currently is, again, if I plug in 1, I get 2. If I plug in 2, I get 4. So similar to what we did here, let's try to fix it. I want this to become a 1. I want 4 to become a 3. So to fix it, let's just subtract 1 off of it. And that will do it. We can see now that this formula does fit that sequence right there. We have 2 more. This one takes a bit of intuition. Notice how I'm always writing 1, 2, 3, 4, 5. That should help you because I'm saying you got to plug in these numbers to generate these values. In a way, it's kind of like thinking of a chart where we're trying to make the formula given this information here. So that's kind of what I'm thinking about in my head. And if I look at these numbers, we should see a relationship. It's simply squared. So a sub n is going to be n squared. And this last one, this is probably the hardest one, we should immediately notice that these are alternating, positive, negative, positive, negative. So to do that, we're going to take that piece from up here. That's right, -1 to the n plus 1. Now notice how I put a plus 1 here. If I just put an n, that wouldn't be good because this would make the first term negative, and I want that first term to be positive. So I'm going to put a plus 1 right there. And now that that takes care of the signs, let's just focus on the actual values there. There's always a 1 on the numerator, and the bottom is just going up by 1, so that will actually match our input changing. So it should just be 1 over n. And we got it. Now we're almost done. The next example is using a recursion formula. Find the first 4 terms of the sequence in which a1 or a sub 1 is 5. So I can write that. And then it gives us this new notation. A sub n is equal to 3 times a sub n minus 1 plus 2 for n is greater than or equal to 2. So I want you to highlight this. This is called recursion. And this in particular, that's a recursive formula. Now the way the recursive formula works is that this thing is saying, in order to get the next term, you have to do something to the previous term. And this part in particular is important. This n is greater than or equal to 2. What that means is you're going to use the formula at this point, meaning it's kind of like an instruction. It tells you when the formula begins. So in a way, this a1 equals 5 is like the trigger point, and after we've established where we're starting, this thing will kick in. So for example, if I want a sub 2, I have to do 3 times my previous term, which is 5, and then add 2. Therefore, a sub 2 is 17. So if I want the next term, I have to do 3 times my previous term, which is 17, and add 2, which is 53. So if I want my next term, I got to do 3 times my previous term, which is 53, and add 2, which would be 161. So right there are the first 4 terms. So let's try it one more time. It says write down the first 5 terms of the following recursively defined sequence. And to fix it, this should actually say for n is greater than or equal to 2, because we want this formula to kick in at the second term. So the first term is 1. Now to get the second term, it says n times your previous. So again, this is your previous. And then notice how it gives you an n. That just means you're going to plug in whatever number term we want. So if I'm looking for the second term, n should be 2 times it by your previous, which is 2. So for the third term, now I'm going to have 3 times my previous, which is 6. Now for the fourth term, I want 4 times my previous, that's 24. And finally the fifth term, that's 5th times my previous, 120. And there are the first 5 terms. Now the final thing to go over is going to be this little piece right here. I'm not too sure if you learned this yet, but we have to go over this. This is pretty fast. I put this definition for you, the factorial symbol. So factorial is simply going to be this exclamation point. And here's some definitions for you. So 0 factorial is 1, 1 factorial is 1. What it essentially means is you just multiply down by subtracting 1. So n factorial is defined right here. So 3 factorial means 3 times 2 times 1. So notice how we just multiply everything by the number that's 1 lower until you hit 1. So 3 factorial would be 6. So for this example, 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. So if you're good at this, you can recognize that the 3, 2, and 1 don't matter, and you're left with 20. Now when you get more advanced, this is a little more advanced here, you can kind of break the numbers off. So it's 5 times 4 times 3 factorial over 3 factorial. Those cancel, you're left with 20. Okay, so that's it. Let me know if you have any questions, and I'll see you in class.